Question 4D. Methane, CH4, is an alkane. What is the general formula for alkanes? So methane, there we know that methane is one carbon. So that's C1H4. We don't tend to write it like this, but it can be useful in this way just because I know here that if N is 1, that would be C1H1. Well, that's not right. If N was 1, then it'd be C1H times 2N, be H2. Well, that's not right. This one, C1H, well, 2N, which is 2 times 1, so N is 1. Take away 2, H0, well, that's not right. Here I've got, if N is 1, so I'm imagining here that N equals 1, because that's the first one, N equals 1, I've got C1H, 2N is 2 plus 2, H4. Perfect, it's that one there. Okay, to be honest, I knew it was that one there because I'd eliminated the other ones before, but that's an easy way of checking. The question here was really generous because they gave us this information, but if they didn't, if I look back at question C, part C of this question, they'd actually given me this diagram, which I'd already worked out as that, and if I do a quick check, here N is 3, so 2 times 3 is 6, plus 2 is 8, yep, so that also works as well. Alkanes burn in oxygen. Balance the equation for methane burning. So balance the equation for methane burning, so it's 1 mark. So there's all sorts of ways that different teachers do this. Personally, I like to use the bubble method, and I'm going to try and remember how to do that right now for you, but it's all about remembering where this is here. That's the balance point there. So I'm going to have C, H, 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 that's 1 molecule on this side. I've got OO, which is the other molecule here. That gives me CO2, which is, I'm going to put my line down there, COO, and H2O, H, HO. Okay, so that's what's inside. Each of those letters there represents one atom, and I put the circle around it to show that that's my molecule. Now what I'm going to do is I need to get the same number of things on both sides. So I'm going to look at the carbons first of all, because that's the first. I always leave oxygen and hydrogen to the last. So there's carbons, so I've got 1 carbon there on this side, 1 carbon there, okay, so I'm happy with the carbons. Let's look at hydrogen next. 4 hydrogens, but over here I've only got 2 hydrogens over there. Now the only thing I can do is add an entire bubble. I'm not allowed to add individual letters, I have to add a whole bubble. So I've added the whole bubble there of that. So I've now got 4 hydrogens here, 1, 2, 3, 4 there. Just check carbons the same, 1, 1, yeah. Now check my oxygens, I've got 1, 2 on this side and 1, 2, 3, 4 on that side. So I need more over here, and all I can ever do is add entire molecules. There we go, so I've got 1, 2, 3, 4, 1, 2, 3, 4, perfect, they're balanced. Now I just count up the number of molecules of each one. So I've got 1 of these, so I'm going to leave that as it is. I could possibly, if I wanted to, I could write 1, but I wouldn't need to. 1 there. I've got 2 oxygens here, so 2 molecules, and I've got 1 of those. So in fact, do you know what? We don't tend to write the 1, so I'm just going to leave it. 2 there, and over here I've got 2 of these. Okay, and that's it. Ethene is an alkene. Which reagent is used to test for alkenes? And it's tick 1 box. It's worth 1 mark. Okay, so this is one you just ultimately sort of got to remember, I guess, for this. We know that lime water is the test for carbon dioxide, so we know it's not that. Litmus paper is all about pH. Okay, so it's not that. Anhydrous copper sulfate, that's a test for water. The anhydrous means it's without water. Hydro, remember, means water. Okay, so whenever you see hydro, you always think of water. So it's not that one either. It is bromine water. That's the test for alkenes. Okay, that might be one you just need to try and remember though. Okay, hope that helps.